So this lesson is on solving polynomial equations, and a lot of this is review. We're just putting a couple of topics together. We've seen review of some factoring as well as some new factoring, and we're going to remind ourselves how to solve an equation that is set equal to 0. So the first step in solving our polynomial equations is we want to get them equal to 0. Remember, we're going to be using the zero product property. If we can get it factored, and we have terms that are multiplied by one another to equal 0, we can set each term equal to 0 to solve. So that's our first step. Second step, anytime we factor, we always look for a GCF first. So as I glance through my first example, I don't see any common factors that I can pull out of all 4 terms. So then I'm going to look for the different types of factoring that we've seen so far. Remember, for grouping, you're going to want to look for 4 terms. Difference of squares would be a binomial. Difference, of course, means subtracting. And then perfect squares. T-chart is if it's in that quadratic formula as well as the AC method. And then finally the sum or difference of cubes. Of course, you have to have those perfect cubes memorized. So we've got 4 terms. That's probably going to be factoring by grouping. So I'm going to start by looking at my first 2 terms. GCF would be x squared. Factoring that out, I'm left with 3x plus 2. Second 2 terms, my GCF is negative 4. Dividing that out, I get 3x plus 2. Don't lose your equation. We're not just factoring, we're solving an equation. So we got equals 0. Looking at my 2 terms now, I've got my 3x plus 2 as a common factor, leaving me with the x squared minus 4. And then to finish factoring, I notice a difference of squares, the x squared minus 4. So we factor that into the x plus 2, x minus 2. Can I keep factoring? The answer is now no, so I'm going to look at step 5, using the zero product property to solve. So remember, we've got 3x plus 2 times x plus 2 times x minus 2. So that means at least one of those terms has to equal 0 if we are multiplying to 0. So we set each piece equal to 0 and solve for x. So on our first one, subtract 2, divide by 3. Second one, I'm combining the second 2 answers. Our second one, we would subtract 2 to get a negative 2. And our third one, we would add 2 to get a positive 2. So we've got plus or minus 2 from those last 2 answers. All right, part B, looking at this one, I notice y cubed equals 64, which is not equal to 0. So my first step, set it equal to 0. I'm going to subtract 64 from both sides. Second step, always look for GCF. I don't have one on this one, so I'm going to look for how else I might factor it. Well, I see the y cubed, and that makes me think sum or difference of cubes, which is what I have. 64 is a perfect cube. So I'm going to factor this using that new method that we learned. Cube root of y cubed. Cube root of 64 is 4. Keep the same sign. And then in that second set, we're going to take y squared. Opposite sign, so plus sign. Multiply the 4 and the y. Always a plus sign for that third term. And then the 4 squared gives us 16. Still equal to 0. Can I keep factoring? When you factor a sum or difference of cubes, the answer is no. That second term, that's the quadratic, will not factor. So, zero product property, set each piece equal to 0. First one, fairly easy to solve. I'm going to add 4 to both sides. The second one, because I already know it doesn't factor, I'm going to use the quadratic formula to solve. This is going to look a little unusual because my variable is y, so I'm going to set y equal to negative b plus or minus the square root, b squared minus 4 times a times c, all over 2a. And we're going to give our answer in simplest radical form. So I'm going to start by evaluating what's under the radical. 16 minus 64 is negative 48. Simplifying my radical, I've got a negative under the radical, so I'm going to pull that I out, the imaginary number. And 48 has a perfect square factor of 16. 48 is 16 times 3. Square root of 16 is 4, so we've got 4I times the square root of 3. And then when you have a fraction where you've got two terms in the numerator and one in the denominator, in order to simplify this overall, that denominator has to go into both terms in the numerator. Looking at both of the 4s, I'm going to divide my two 4s and my 2 by 2, so I get negative 2 plus or minus 2I square root of 3.